mixed examples. What I mean by this is typically when you have to name or write a formula for a compound, you're not told if you're following the binary ionic rules or the ternary rules. So really today what we're going to look at is a lot of sorting. So when you look at these compounds, kind of thinking about how you would know if you're going to use table E, if you're going to use a Roman numeral, etc. What I tend to find that kind of makes things easier for me is to first identify if I'm using table E. So what identifies for me if I'm using table E is looking at how many capital letters I have. So clearly I have a situation here where I have more than two, more than two, more than two, more than two. I'm moving these down for my ability to see more things on the screen here. More than two, more than two, more than two. So that automatically tells me that I've done follow my table E rules. Now I can kind of separate out my binary stock and two nonmetals. So binary just means regular old opposite sides of the staircase ionic naming. So all of the examples that I have remaining should have just two capital letters in them. Now I just have to identify which of these types of naming they are. So in order to determine if something is binary ionic, I'm actually going to use my periodic table to tell if they're opposite sides of the staircase. So place your fingers on BA and I. I have two capital letters, opposite sides of the staircase, binary ionic. Place your fingers on O and F. Two capital letters, same side of the staircase, will be two nonmetals, and we will use a prefix there. The other thing we have to watch out for is if we're using the stock system or a Roman numeral. Remember, we're looking there for multiple oxidation states. So you should have opposite sides of the staircase, and your metal should have multiple charges. Let's look at an example of one of those. Put your finger on Cu and Cl. Opposite sides of the staircase, copper has more than one charge. So both of these compounds fall into that category. So let's sort the remaining compounds that we have. CaS, opposite sides, only one charge. SiF, same side of the staircase. CO2, same side of the staircase. Fe2O3, opposite sides, we have a metal with multiple charges. PCl5, same side of the staircase. AlF, opposite sides, only one charge, good old binary ionic. Vanadium oxide will need a Roman numeral. Same side of the staircase. Manganese oxide, we do have multiple charges there. And rubidium only has one charge, that is opposite sides of the staircase. I have left sulfur, or H and S up there. We actually pretend that hydrogen is on the right side of the staircase. So this is actually a little bit of a rule breaker, it seems, but hydrogen is a nonmetal, so that's technically the same side of the staircase. So I'd like you to think about what you actually had to ask yourself to get to this point. First thing we asked ourselves is how many capital letters we have. If your answer to how many capital letters you have is 3 or more, then you can go right into ternary naming, and that is our table E naming. And you can go back over those steps, but again, we would name the first thing, name the second thing. If it's from table E, we don't change its ending. If we only have two capital letters, so just two, no more than that, that tells us we have two elements in the compound. We have two choices. Actually, let me put this right up here. Two capital letters. And then we can consider our next question, which is going to be, are they on the same side of the staircase? So this is a simple yes or no question. We just have to remember hydrogen's a little bit of an exception. So if the elements are on the same side of the staircase, we're going to use prefix naming. Remember, we just named the first element, second element. We use prefixes to tell how many, and we will change our ending here to I because these are coming from the periodic table. If they are not on the same side of the staircase, we have to actually let me do this one more time. Sorry. We have to ask ourselves: do we have multiple positive oxidation states for our metal? If the answer to this is yes, then we are going to use our stock system naming, which remember we'll be using a Roman numeral. And generally, if it comes from the periodic table, we will still change its ending to I. If the answer to this is no, we will use simple binary naming, which is simply name the first thing, name the second thing, change the ending to I. Next, we have to think about if we're going to identify a name and then have to write it into a formula. So the first thing I like to look for here is something that jumps out at me. A lot of people say Roman numerals jump out at them. So I'm going to grab my Roman numerals, write them down here. So I've sorted out all of those Roman numerals. The next thing I'm going to look at is something else that separates some of these from each other. I think the next thing that jumps out at me is the endings of some of the names. So look for some endings like ate, ite, things like that that might be from table E. Those would be the ones that we're immediately going to pull down and put into our ternary category. All right, so all my remaining endings are "-ide." Sorry, I guess I forgot to put that one in there before. All of our remaining endings are "-ide." What I would look for next is, does the name have prefixes? And you can even double check if it's the same side of the staircase. So phosphorus hexasulfide has a prefix. That's automatically got to be a prefix name, obviously. If you put your finger on phosphorus and sulfur, they're on the same side of the staircase. So let's pull a few more of those out that have prefixes in them. So everything left at this point should go in my binary column. I actually have a couple here that are a little bit tricky that don't go in that column. So let's take a minute and look at each of these. We should double check that they're regular binary, they're opposite sides of the staircase, and that they don't have prefixes. Aluminum oxide, fine. Zinc chloride is fine. Calcium sulfide is fine. If you go through and check each of those, they're all simply two elements, opposite sides of the staircase, and none of the metals have multiple charges. The two that I've left are tricky. What's tricky about ammonium is it ends in iodide, so it looks binary. However, ammonium is from table E. What's also tricky about sodium hydroxide, hydroxide is not the same thing as hydride, which would be plain old hydrogen. So sodium hydroxide is actually a ternary compound from reference table E. So what you need to be able to do is make yourself a nice flow chart that helps you to separate out your names. You will be able to use this flow chart on an upcoming quiz, so you want to do a nice job with it. What you can't do is simply write down a bunch of examples. So think about the things that you would ask yourself when you just try to sort the names or the formulas. Did you look at endings? Did you look for prefixes? What other kinds of clues help you to know how to do your naming when your examples are all mixed? So again, you are going to be able to make a flow chart that you can use and use it on, and you will be able to use it on the quiz, but not the test.